Good afternoon. I'm Trinh from VNPT.
Hi, I'm Daisuke Hara from NTT. Today, we'd like to present our joint activity. Our title is OVSPP, Hybrid Enhanced vSwitch for Code-Based Service Function Chaining.
Our agenda is follow. The first is importance of service function chaining for telco. The second, we present how to implement SFC in core system. The third, we present about SPP, the software suite that developed based on DPDK by NTT. The fourth, we state the problem, and then we analyze the problem. And we propose our solution is OVSPP combined between the OVS and the SPP. And we present our experiment and some preliminary results. The first, we present the importance of service function chaining for telco. We are telco and we are very interested in this kind of use case that we want to migrate the network function from the customer side to the access network of the telco. So we will have both the customer and telco will have a lot of benefit. First, it's easy to add new function, easy to maintain, and OPEX. Customer will pay the OPEX instead of the CAPEX, and save the service space, save the electricity, and not noisy. And telco will get some money from customer. I think the thing that make the migration work is that we have very low delay between the customer side and the access network of the operator. And but with this use case, if we don't have the service function chaining, the operator can only provide one service, such as file one or load balancing to the customer. They cannot provide many services to one customer. So the service function chaining is very important in this use case. Based on the interesting in the use case, we build a roadmap. It's in VNPT. First, we build some use case. Second, we implement some child in VNPT, and we find some problem, and we build the code in a box. Then we want to build the code rack, and we want to deploy commercially. And now we are in the code in a box phase. And with code in a box, we play with the vSwitch, vSwitch, SFC, vCPE, and OLT. And we want to present a little bit about our research project of implement the vCPE child in VNPT. This kind of vCPE child we implement in our list line internet. So the customer, when coming to the PE router, if the customer ran meet the box traffic, meet the box, the traffic will be classified by the VLAN and will be mapped to our MAS server and mapped to another PA router to go to the internet. And the customer will be happy because they can have the customer portal to control their meet the box service, such as is a file one. In here, we implement the Vieta file one, and customer can go to the customer portal to configure the file one and see the traffic running through their network. And we also test with the layer 3 file 1, layer 4 file 1, layer 7 file 1, and IPS, IDS, and bandwidth limit. And we also test the performance of the system. But our system works on the C6 server, and we build the VM on the C6 server. So the performance of the system is not so good. And this system also uses manual control. It's not good because if the one meet the box die, it cannot automatically recovery to the second meter box. And this system also don't provide a service function chaining. And this system also wastes the resource because we can provide to the customer only kind of the VM. We cannot provide the container. And this system have not good performance. And then we found the code system. I think the code system is a very, very nice one. And we want to try is to replace our C6 server to provide the service of virtual CP for the customer. But the cost system can solve the problem of the manual control because cost system have the XOS to automatically control of the system. And cost system also have the VM or container to provide the mid-box service to the customer. But the cost system still, as I know, still don't have the service function chaining because as a flow like that, it only go through one meter box. And the cost system, the switching in the cost system is also not so good. And in our practical needs is the service function chaining. So we want to provide many service to each customer. So each customer will be provided by one service function chaining like this. How to implement the SFC in cost system, and we found some solution to implement the SFC in the cost. First, we will use a Linux bridge to connect among the network among the meter box. The second, we use a virtual Ethernet pair to connect among the meter box to do the service function chaining. The third one, we use the OVS chaining. We implement the open vSwitch on the VSGVM to connect among the meter box. And the fourth one, we use the OpenNet VM. It's a kind of state of the art for the network function chaining. To see here, we see as the result, we see that the first solution with Linux bridge is have low performance. With the virtual Ethernet pair, it also have low performance, and with OVS chaining, it also have low performance. With OpenNet VM, we think it have high performance, but we need to modify the application to run on the OpenNet VM because OpenNet VM provide a kind of NF flip, and we have to use app to use that NF flip. And this is our solution. We in NTT develop a kind of the software suite. We call it SPP. It's very simplified switch, but it's fast and it's very suitable to the service function chaining. And we want to implement the switch SPP based on DPDK on each VSGVM, and also to switch among the network function. And we also implement the SPP above the Open vSwitch to have the Open vSwitch to switch the SFC, which span many VSGVM. So we will do it to switch among the VM and implement the SPP inside each VSGVM to switch among the container. Yeah.
Okay, I'd like to introduce our self-developed vSwitch. named Soft Patch Panel SPP. SPP is one of the vSwitch leveraging DPDK to meet two requirements. One requirement is flexibility for configuring connections. The other is high performance for forwarding huge amount of packets. So SPP provides an easy-to-understand operations for assigning resources, like a patch panel. By using control terminal or calling APIs, operator can reconfigure connections between VMs dynamically while running applications. No need to stop applications. So NTT, SPP employs very simple mechanism. That's it, just connecting the ports. By this approach and using DPDK enables high performance, that is high throughput. SPP provides two DPDK interfaces. One is ring, the other is vhost. Ring is kind of shared memory. It enables zero copy packet forwarding. vHost is a paravirtualization technology to complete packet processing in user RAN. This is basic performance evaluation. So we use L2 forwarding sample DPDK applications. SPP ring achieves the highest performance, nearly 14.88 megapps, and SPP vHost is 1.5 to 1.8 times better than OBS DPDK. Currently, SPP ring can be used for containers, and SPP vHost can be used for VMs. There are several solutions to virtualize networks, but nothing satisfies all the requirements, include high speed, flexibility, and availability. So SPP is suitable for use case where flexibility and availability are required. Although SPP has a limit on high speed, it roughly 10 to 12 kbps and more. It depends on the hardware spec and tuning, performance tuning.
Yeah, so to implement the SPP in the codes, we realize the problem like this. The SFC when implemented in code platform suffer a serious performance issue of overwhelmed switching entry. It adds to cost open vSwitch. We think service function chaining will add a lot of switching entry to the Open vSwitch because it has to switch among many service chaining inside one VSG VM, and it also has to switch among the VSG VM. And based on the paper in here, data plane specialization for high performance open flow software switching, we see they show the result that when there are a lot of number of active flow in the Open vSwitch, the performance, the packet rate of Open vSwitch will be downgraded a lot, as in the graph. We also inspired by some paper in here that they want, in here they have the static compilation and dynamic compilation they use the dynamic compilation to compile the data path, to make the data path only suitable to the use case that they use. So we inspired by that idea, we also want to customize our SPP switch to only suitable to service function chaining and work in that case. So we don't use a dynamic compilation, but we customize the SPP to suitable to only the use case of service function chaining. So that is the reason why we want to implement the SPP to support the Open vSwitch in the code platform to do the service function chaining. Here is our solution. We implement the SPP DPDK on each VSG VM, and we do the chaining of the two network function. In fact, now we use only test PMD, but in the future we will implement some network function there. We also want to implement the SPP DPDK on the Open vSwitch to have switching among the VSG VM. And this is our experiment. For implementing the SPP DPDK, we implement it on each VSG VM. And for testing, we implement the test client 2 on the compute node 1. And we build a Python file to put the traffic, to put a lot of flow to the Open vSwitch using REST API. And to make that kind of the flow active, we use SCAPI to grab the packet and send the packet to many packets, match each flow to the Open vSwitch, and make the flow, activate the flow. And after that, we use iPerf in test client 2 to send the traffic to the Open vSwitch, and it will go through the tab 8 port of Open vSwitch and go to the SPP DPDK and go to the two network function and go back to the Open vSwitch and go out to through the data path, go to the internet and go to the port of the host. And we test with the TCP and UDP traffic. And we also use a netperf from test client to send the traffic to the host NIC to test the delay of the traffic. That is implementation of the SPP DPDK. About the Open vSwitch DPDK, we also compare the SPP with Open vSwitch when we implement the Open vSwitch DPDK instead of the SPP DPDK on VSG VM. To measure the traffic when we use a virtual Ethernet pair, we use a test client 1 from head node, and we send the traffic through the data path through Open vSwitch and go through the two network function. but we use a virtual Ethernet pair to connect to network to meet the box and let it go to the internet. And also we also use the iPerf and NetPerf to measure the throughput and the delay of the system. And this is a primary result. This is UDP throughput between SPP virtual Ethernet pair and the open vSwitch chaining. And this is TCP, and this is the delay. It is only the preliminary result. That is the result. And this is I want to say about our status of work. The current status, we already implement the SPP DPDK on VSCVM. And we also want to implement the SPP DPDK for switching of NFC among the VSCVM. And we also want to implement many VNF, many kind of VNF such as IDF, virtual firewall, and load balancing on our SPP DPDK.
So this collaboration work belongs to APAC Telecom Innovation Initiative, ATI. So ATI is established in April 2017 by NTT and Telecom Indonesia. So VNPT also joined ATI. This initiative is aimed to promote the creation of new network service, considering social problem in the APAC region, and to promote the technical studies. Currently, there are 5 working projects. We, WP4, working project 4, focus on vSwitch for service function chaining. In your working project, we aim to propose high-performance service function chaining architecture and to prove the architecture through joint POC activity. So Telecom Indonesia and VNPT propose use cases, NTT provide SPP. And we are applying SPP, the use cases, and prove the use case through the joint POC. Okay, that's all. Thank you so much.
Do you have any trial plans, real customers, real functions that you have in your roadmap? Deployments?
In roadmap, in fact, in the past, the customer really want to do the telemetry because in our country, the customer the office there are many staff, but the staff they use some staff they download peer to peer and it get all of the traffic. So the customer want to know who get the traffic to get all of the bandwidth of the office. So we want to implement it, and there's one function that bandwidth limit, and if we find out who get all of the traffic, we can recommend and we limit the traffic of the customer. And I think that is the feature the customer likes most. Yeah.
So you use the word customer. So you have requirements that you're trying to meet, specific, that example that you had, that's a customer requirement, or?
Yeah, in fact, in the past, we work with customer, and but we talk with many customer, and we see that the customer like that kind of feature, and we want to implement the feature in this code. Because this child is a simple one, we have not implemented to the customer because the performance is not so good. But we already talked with many customers, and they said that they really want the telemetry feature of the system.
You may have addressed it or may not have addressed it. With it being, a soft patch panel, do you kind of have set expectations for how quickly you can reconfigure your port assignments across that patch panel, or do you envision it as more of a, if I want to move these assignments, you do that post, when for lack of a better term, a maintenance window, or is it dynamic? So if you've got open flow controlled OVS, you can do it more from than a VETH pair or a single PHY port, and you start to drill down into what the open flow commands were. It sounds like you'd have a soft patch panel that would do load balancing, at least by protocol, if not by potentially session. We've got a lot of problems in that space. Do you see this beginning to address that area? Or is it just literally a patch panel, configure it, set your configuration, make sure you get the packets per second numbers up, and then if you want to reconfigure it, you reconfigure it during in essence, a maintenance window?
Yes, as I understand, you want to ask about the feature of the SPP, is that right? So the SPP, we have the patch, it works as the same as a patch panel.
Right.
And it also has some better feature to support the service function chaining. It can realize the VLAN if we use a secondary process to realize the VLAN, to switch the traffic based on VLAN also, because we think the VLAN is also important for service function chaining.
But do you imagine changing the service chain dynamically, perhaps under control of an ONOS?
Right.
Or is it more of a fixed configuration?
Yeah, in current state, we have the REST API for control our SPP. But to integrate it with the ONOS, we need time to do it. Now we only provide the CLI and REST API, so the other app can program and
But you
control.
couldn't do that dynamically.
Yeah.
Change.
Yeah. I think we could, because we can do it. Yeah. Thank you very much.